Hi, let's talk about solving cubic equations, more specifically solving a cubic equation given a factor or a solution. So this lesson is a continuation on factoring and solving by graphing. You still need to know all of those things. Let's just do a really quick review. You may want to grab your highlighter. Remember that cubic equations, they have three solutions. Either they're going to have one real solution with two imaginaries, or all three are going to be real. And you've learned that if you graph it, that all of the real solutions will show up on the x-axis, and they're called x-intercepts. Solutions are often referred to as either roots or zeros. I use the word solution a lot in class, but anything else, practice, your end of course, the benchmark, your ACT, they could also say roots or zeros. It all means the same thing. Now there's a mathematical notation for the solution of a function, and it's where f of x is equal to 0. That is for a solution. So whenever they say f of x equals 0 or find when the function is equal to 0, it's kind of code or mathematical notation for what is the solution. Whenever you factor a function, it needs to be in standard form, and it does need to be equal to 0, hence the notation. The factor theorem also states that if you plug in or substitute 3 and your result is 0, that means that x minus 3 is a factor and 3 is a solution. So whenever you wind up with f of 3 equals 0, it tells you lots of things. It says, hey, it's not going to have a remainder if you divide by x minus 3, and if you graph it, the equation or that polynomial is going to cross over at positive 3 on the x-axis. Okay, so before we get into the new stuff, we're going to practice this function notation, this factor theorem, okay? Now, in the previous lesson, what you did is you used the factor theorem to test to see whether or not it is a factor. Now that you know that whenever you test it and the result is 0, you know that that is going to actually be a solution, okay? And you can work backwards and you can find that factor. So let's take a look at this table here. So right here it says if f of 4 is equal to 0, now that means if you plug in a 4 into your polynomial and your result is 0, then that means the remainder of 0, that's going to wind up being a solution. So in the last lesson, you covered the first three columns. And the first three columns is that notation, function notation, whether or not it has a remainder or not. And if the remainder is 0, then yes, it's a solution. So what we're going to do is we're going to focus more on if it is, then we're going to write what the solution is and what the factor is. So if you know you plugged in a 4 and you get 0, then it is a solution. Therefore, you can say that 4 is a solution, and you can work backwards and say x minus 4 is a factor. So likewise, if you wind up with f of negative 8 and you plug that in and you test it and you wind up with a 5 as a result, your remainder is 5. Now, if your remainder is anything other than 0, it is not going to be a solution. If it's not a solution, then you cannot write the solution and you cannot write the factor. So we're out of options. So in the next case, if you plug in negative 3, you wind up with a result of 0, which means you have a 0 as a remainder. Yes, that is going to be a solution. So I'm going to write the solution as x equals negative 3. So whatever you plug in will be the solution as long as the result is 0. But then you can go backwards and say that the factor is going to be x plus 3. Make sure that these are opposite signs. Next line says, what happens if you plug in a positive 6? If you plug in a positive 6, you wind up with a remainder of negative 2, which means no, it is not a solution, and you cannot fill out the rest of the information on that row. So I'm going to work through the next 2 rows, and then I want you to pause the video after that, and I want you to attempt to finish the rest of the chart. All right, the only information it gives us here is x is equal to negative 9. So I know that negative 9 is a solution. If negative 9 is a solution, then I can use the opposite and say x plus 9 is a factor. It is a solution, so I'm going to put yes here. If it is a solution, what do I plug in? I plug in negative 9. And when I plug in the solution, I wind up with no remainder, and that's how you fill out this chart. Next line says you have x plus 5. It is definitely a factor, so if x plus 5 is a factor, then you know that negative 5 is a solution. If you plug in negative 5, if it's a solution, then your result should be 0, which means your remainder is 0, and absolutely yes. Okay, go ahead and pause the video and try to fill out the next two lines. Okay, so the last two lines, we have a solution of 1/2, which means if you plug in 1/2, our remainder should be 0. And if we have 1/2 as a solution, then our factor would be x minus 1/2. The last one's a little bit tricky because it's just x. You can't see what you're adding to it. So if you can't see it, you should kind of know in the back of your head that you are adding 0. So if you're adding 0, then your solution is going to wind up being the opposite of 0, which is still 0. So really no tricks there. It just looks kind of weird. And if you plug in 0, your result is 0. So you have no remainder, and yes, it is a solution, and x is your factor. So you're definitely going to need about 2 or 3 highlighters for this section because this is more visual. We're not really doing anything. I just need you to kind of pull everything that we've done in the last, few lessons and just kind of tie it all together. So what we're going to do is we're going to highlight this side right here. This is going to be one of your factors. And then this is going to be your second factor, okay? But a while ago, and this is, 2 or 3 lessons ago, you were learning how to multiply. So when you multiply, you would take everything in yellow and multiply that times everything in blue. And a 2 by 3 would give you 6 individual terms. So your final answer would be you kind of just adding up all of your like terms, but you noticed that your diagonals would add together. So you'd wind up with x to the third, and then it would be plus 5x, and then that would be 5x squared, and then plus 5x, and then minus 2. So this top thing up here kind of models your area multiplication, okay? And all of your results, and I don't want to highlight this yet, but all of your results, actually, yes, I do. It's going to be everything in here, but you do have some like terms, okay? The second one, though, instead of looking at it as an area, it's going to be more like factored. Okay, so we're going to start with what is inside the box, and then we're going to look for greatest common factors, and that GCF to the left would be x plus 2, and the GCF on the top would be x squared plus 3x minus 1. The last one models division, and factors are the result of dividing, but you kind of express it in a different way. So if you were taking everything in the box, which is pink, and you divide that by what is on the left, which is x plus 2, you wind up with the result of what is on the top. So all of these mean the same thing, they're just written in a different way, okay?